Hello students. In this video, I am going to solve numerical problems of exercise 2C 1 to 8 of chapter Motion in One Dimension from the book Concise Physics for ICSE grade 9. These are some of the formulas that I will be using while solving the numericals. First numerical. A body starts from rest with a uniform acceleration of 2 meter per second square. Find the distance covered by the body in 2 seconds. So here initial velocity is 0. Acceleration is given 2 meter per second square. We want to find out the distance covered in 2 seconds. So time is given 2 seconds. So based on the information given here, we can use the formula S is equal to ut plus half at square. Remember, almost 95% numericals of motion in one dimension can be solved using this formula. So S is equal to 0 since initial velocity is 0 plus half acceleration is 2, time is 2. So we get S is equal to 4 meter. Distance covered is 4 meter. Next question. A body starts with an initial velocity of 10 meter per second and acceleration 5 meter per second square. Find the distance covered by it in 5 seconds. So here initial velocity is given 10 meter per second. Acceleration is also given 5 meter per second square. We want to find out the distance covered, that is S, in 5 seconds. So T is equal to 5 seconds. Once again we can use the formula S is equal to ut plus half at square. Initial velocity is 10, time taken is 5 seconds plus half, acceleration is 5 and time is 5 seconds. So this is 10 into 5, 50 plus half into 5 into 25, that is 50 plus 125 divided by 2, that is 50 plus 62.5, and hence the distance is 112.5 meter. Third numerical. A vehicle is accelerating on a straight road. Its velocity at any instant is 30 kilometers per hour. So first velocity is given 30 kilometers per hour. Let us say u is equal to 30 kilometers per hour. After 2 seconds, it is 33.6 kilometers per hour. Okay, so time is given 2 seconds, and at the end of 2 seconds, the velocity value is given 33.6 kilometers per hour. So let us label that velocity as V1, 33.6 kilometers per hour. And after further 2 seconds, okay, so let us write this time as T2, 2 seconds, velocity becomes 37.2 kilometers per hour. Find the acceleration of the vehicle in meter per second square, and is the acceleration uniform? That is the question. So here first I will find out the difference in velocity in kilometer per hour only. Then I will convert that difference in meter per second, and then I will find out the acceleration in meter per second square. So first difference in velocity for the first 2 seconds is 33.6 minus 30, that is 3.6 kilometer per hour. And now if we convert this into meters per second, 1 kilometer per hour is 5 upon 18 meter per second. So this becomes 1 meter per second. So acceleration is change in velocity upon time, 1 upon 2, 0.5 meter per second square. So this is the acceleration in initial 2 seconds. In later or in further 2 seconds, what is the acceleration? So for that, once again I will find out delta V in kilometers per hour, that is 37.2 minus 33.6, and this difference is 3.6 kilometer per hour. Once again converting this kilometer per hour into meter per second, we have to multiply it by 5 by 18, and the answer is 1 meter per second. So acceleration is delta V upon T half, or 0.5 meter per second square. So from these two values of acceleration, we can say that acceleration is uniform. Numerical number 4. A body initially at rest, so we can say u is equal to 0, starts moving with a constant acceleration 2 meter per second square. Acceleration is given 2 meter per second square. Calculate the velocity acquired. Calculate the velocity acquired, that is v, and distance traveled in 5 seconds. So first, to find out the velocity, we can use the formula v is equal to u plus 80, but u is 0, acceleration is 2 and time is 5. So velocity is 10 meter per second. Now to find out the distance covered, we can use the formula ut plus half a t square. The first term is 0 plus half into acceleration is 2 and time is 5. So distance becomes 25 meter. Fifth numerical. A bullet initially moving with a velocity 20 meter per second strikes a target and comes to rest after penetrating distance 10 centimeter in the target. So initial velocity is 20, final velocity will be 0 because the bullet becomes stationary after penetrating certain distance. Distance is 10 centimeter, and if we convert this in meter, that is 0.1 meter. Calculate the retardation caused by the target. So here we can use the formula v square minus u square is equal to 2as. See here we will not be able to use the formula s is equal to ut plus half at square, right, because time is not given. So only one choice left with us is to use this equation v square minus u square is equal to 2as. Final velocity is 0, initial velocity 20, so 0 minus 20 square is equal to 2. Acceleration we want to find out and distance is 0.1. So we get minus 400 upon 0.2 is equal to acceleration. So here acceleration comes out minus 2000 meter per second square. And we know that if acceleration is negative, that is known as retardation. So retardation is equal to 2000 meter per second square. Sixth, a train moving with a velocity of 20 meter per second is brought to rest by applying brakes in 5 seconds. Calculate retardation. U is equal to 20 meter per second. Final velocity is 0 because object is brought to rest. Time 5 seconds. Find the acceleration. A is equal to V minus U upon T. So A is equal to final velocity 0, initial velocity 20, so 0 minus 20 upon time 5. So A is equal to minus 4 meter per second square, and hence we can write retardation is equal to 4 meter per second square. Seventh, a train travels with a speed of 60 kilometers per hour from station A to station B and then comes back with the speed 80 kilometers per hour from station B to station A. Find the average speed and the average velocity. So the distance from station A to station B is covered with the speed 60 kilometers per hour, and the distance from B to A is covered with the speed 80 kilometers per hour. Now here only speeds are given. So to find out the average velocity, to find out the average speed, we can use the formula 2 V1 V2 upon V1 plus V2. 2 into V1 is 60, V2 is 80 upon 60 plus 80. So when we simplify this, we get the answer 68.57 kilometers per hour. And to find out the average velocity, total displacement upon total time. But since total displacement here is 0, okay, as the train starts from station A and comes back to station A, so displacement is 0. That is why average velocity of the train is 0. Eighth, a train is moving with a speed of 90 kilometers per hour. It is brought to stop by applying the brakes, which produce a retardation of 0.5 meter per second square. Alright, so here initial velocity is given 90 kilometer per hour. To convert into meter per second, multiply by 5 by 18. So 5 into 5, 25 meter per second is the initial speed. Final velocity 0 because it is brought to stop, brought to rest. Retardation is 0.5. So we can say acceleration is minus 0.5 meter per second square. Find the velocity after 10 seconds and the time taken by the train to come to rest. Okay, so first we need to find out velocity after 10 seconds. So V is equal to U plus 80. Initial velocity is 25. Acceleration is minus 0.5 or we can say minus half. 0.5 is half. Time is 10 seconds. Okay, in after 10 seconds, what is the velocity? That is what we want to find out. So 25 minus 5, 20 meter per second. Now, we also want to find out the time taken by the train to come to rest. So for that we can use the formula T is equal to V minus U upon A. Okay, this equation comes from A is equal to V minus U upon T. So if I take T as a subject, I'll get this formula T is equal to V minus U upon A. So T is equal to final velocity 0, initial velocity 25 and acceleration is minus 0.5. That is 250 upon 5 and the answer is 50 seconds. So train takes 50 seconds to stop. Thank you.
Please like, share and subscribe to my channel.